So we are going to discuss reasoning with parallel lines. And if corresponding angles are congruent, meaning their measurements are equal, what do we know? Well, we know that we then have parallel lines. Because if corresponding angles are congruent, or if their measurements are the exact same, that means those lines are parallel. Now let's talk about alternate interior angles. If those are congruent, then we know that we have parallel lines. So really we are looking for the two angle relations that we talked about in the last section, corresponding and alternate interior. And if they are equal in measure, meaning they're congruent, then we're going to have parallel lines. So let's look here. Can we conclude that line A is parallel to line B with what we have? Well, these are corresponding angles, and they are equal in measure, making them congruent. So, yes, we can justify that A is parallel to B because corresponding angles are equal. So those angles are congruent. That is why. Sticking with the corresponding angle theme, here we have corresponding angles. Here and here, those are corresponding. And to make those lines parallel, to prove that those are parallel, our corresponding angles have to be equal. We would have to be equal in measure. So now we're going to find the value of x that makes these equal. This is just solving an equation, which we've been doing all year. So x would have to equal 9. So if we put 9 into x for this expression, this would equal 80, which it does, proving that these lines are parallel. All right, can we conclude that A is parallel to B? Here's A, here's B. Can we conclude that those are parallel? We are going to look at what's given. We have alternate interior angles here. Those are what's given to us. Those are not the same. So no, A is not parallel to. This symbol right here means parallel to, because our alternate interior angles are not equal. So since they're not equal in measure, those lines cannot be parallel. So remember, everything written here, you should pause and write them down. So justifying our reasoning here for these need to be written down in your notes. I have them pre-written just to save some time on the video, not make it as long. So deductive reasoning is, it uses accepted facts to determine if something is true. Like, if line A is parallel to line B, then corresponding angles are congruent. That would be using deductive reasoning. Okay, so we've been using deductive reasoning to prove that these statements are true. So what value of x makes m parallel to n? Let's say this is m and this is n. Okay, so again here we have alternate interior angles. For these lines to be parallel, alternate interior angles, their measurements need to be equal. So now I'm going to solve this expression, or this equation right here. I get x equals -9. X can be a negative number. We can't have a negative angle, but x does not represent the entire angle. X is part of the expression that represents the angle. That is okay to be negative. So in this case, x equals -9. Why does it make it parallel? Because then our alternate interior angles are going to be equal in measure. Which congruent statement justify A being parallel to C? We'll start with that one. Here's A, and here's B. I meant B, not C. We'll start with A being parallel. Now there's lots of statements here. So you can start with any one of these angles. See how angle 1 there is on A, angle 9 here is on B. So if you say that angle 1 equals angle 9, those are corresponding angles. If those angles are equal, that means A is parallel to B. Let's look at a different one. Let's do 7 and 12. See how both 7 and 12 touch A and B? So if angle 7 is equal to angle 12, then you know that A is parallel to B because alternate interior angles are equal. I would like you to come up with your own different statement for that one. And now let's do line C and line D. Come up with new congruent statements here to prove. So we need, let's start with 13 and 15. Let's say that angle 13 equals angle 15. Those are corresponding angles because 13 is in the lower left of its cluster, 15 is in the lower left of that cluster. If those are equal, then line C is parallel to line D. And then let's do 6 and 3. So if angle 3 equals angle 6, okay, see how 6 and 3 touch C and D? And they are alternate interior, where line A is our transversal. 6 and 3, if those are equal, those are alternate interior angles. That is what proves that line C is parallel to line D. I would like you to come up with your own statement that proves C is parallel to D. What value of X makes J parallel to K? Well, both of them are on the same side of the transversal and inside are two lines. When they're on the same side, see how they look like they're different measurements. This is a small acute angle. This is a big obtuse angle. If they look different, they are different. And therefore we have to add them together to equal 180. And now we solve, again, like we've been doing for most of the year. And there is the value of X that makes J parallel to K. And this equation would be our reasoning to explain why. So we want to find the value of X again. So 2x plus 4 plus 3x minus 9 has to equal 180. See, this looks acute, this looks obtuse. When they look different, they are different. We add them together to equal 180. Here I have 5x minus 5 equals 180. Add 5 to each side. 5x equals 185, divide by 5. X equals 37. That would be the value of X that makes those lines parallel. Which lines, if any, here are parallel? Well, I see these two are alternate interior angles, and those two touch lines M and N, with line P being the transversal. So M is parallel to N because alternate interior angles are equal.